Hi everyone, welcome back to the 2016 Hack Summit. We're joined now by Thomas Kurian, who's the President of Product Development at Oracle. He graduated summa cum laude from Princeton and went on to earn an MBA from Stanford School of Business, and he also has an engineering background. And he oversees Oracle's 3,000 plus product development efforts, including Oracle Database, Oracle Fusion Middleware, ERP, CRM, supply chain management applications. And Oracle is also the corporate steward for Java, which is the #1 programming language based on 2016 Indeed.com data. So Thomas, thanks so much for being here with us today.
Thank you for having me.
Great. So this is going to be a fireside chat between myself and Thomas, and we'll be taking audience questions as we go. This is completely unscripted. Thomas doesn't know what I'm going to ask him yet, so we really hope to create a great dialogue here between the two of us. And hopefully this will be educational for some of our audience members. And so Thomas, maybe we can start out by just telling us a little bit more about your personal background. Like, how did you first get interested in being an engineer when you were first in school?
I grew up in India, and in India, my dad was an engineer. He was a chemical engineer. He was the first one in his family to go to school. And so when he grew up, India was just getting independence as a country, and there was a lot of infrastructure projects and opportunities. So he became a chemical engineer. And then I have 3 other brothers. So the 4 of us, 3 of us are engineers and 1's a doctor. And so we sort of grew up saying, we'll become an engineer. But to be perfectly frank with you, when I came to go to college in the United States, the reason I became a programmer was I came to college in the United States, and I didn't realize that things were so expensive. So I was looking for what's the highest paid per hourly job that I could get as a student. And that's when I decided, hey, programming, you get paid a lot of money to write software. And that's frankly how I decided to become a programmer.
Wow, that's great. And what were some of those early programming projects that you worked on back then?
All kinds of stuff. The school where I went, Princeton, had a lab with a lot of silicon graphics machines back then, and these were these amazing, computer graphics workstations. So one of the projects I did was write a lot of visualization software on top of that, and 99% because you could get access to these really powerful, amazingly cool machines. And so we'd work from like 6 p.m. or 7 p.m. till about 2 in the morning. And then there were 28 of these machines in a room. And at 2 in the morning, everybody play Flight Simulator, attacking one another on like this multi-way gaming thing. Back in those days, that was quite something. So that was one. And then I wrote a bunch of stuff for environmental pollution monitoring in rivers. I did a route optimization piece of software for trucking companies, lots of different stuff. Whatever they would pay me to do, I'd do.
That's great. It's funny. Like, I remember those Silicon Valley machines, or sorry, the Silicon Graphics machines. I did some consulting for Silicon Graphics, and I remember going to their office and being blown away by these like Onyx machines, and everything was purple, right? Yeah. I remember just that the raw horsepower out of those machines was unbelievable back then for graphical tasks.
Yes, and so it was a fun time because I was a student, and I never had a computer until I started working, actually, not even in college. And so all the projects I did, I'd have to find a rental computer, something at school where you could use it for a few hours. And these machines were the most state-of-the-art. And so I remember asking, like, how do you get access to one of those machines? And I said, you got to do a project. And so I asked the professor, like, what project could I do that would give me access to those machines? And he said, well, we're writing, visualization software. So we need somebody who can write graphical things around lighting, backlighting, rendering, all of that. And I was like, I don't know anything about it, but happy to learn and write. And so that was the start of that job.
That's awesome, man. And now today, you're working at Oracle, reporting to Larry Ellison, in charge of the software products at Oracle for a $150 billion company, in charge of thousands of software development efforts. That's quite a career path from the programmer who had to rent a computer back in the day. So, one thing that I think is interesting here is dig in a little bit about how that career path happened, because there's a lot of developers in our audience that I think are they're just graduating from school, they're aspiring in their careers. Maybe were there any key moments for you in your career, or things that you learned along the way that maybe other developers could benefit from in their careers?
I think I would say there's three examples of things I learned. The first thing, I think, when the art of writing beautiful software is actually having a really great visual mental picture of the entire system that you're building. And that visual mental picture allows you to simplify the design. Because in my view, great software at the end of the day is actually got to be, the internals of it have got to be beautifully simple and modular in order for the whole system to work. The system itself may do a lot of stuff and may deliver a complex functionality, but if the internals of it are not beautifully simple, these things fall over time. And so the first thing I would tell you is, and for the key product lines at Oracle, I can still visualize the entire design in my head. And that's one of the things that I find, helps as you take on more responsibility, being able to, because you're never going to be a master of every detail, but you need to be able to look at the overall system to help people design, a better and better system. And so that's one thing. The second thing I would say is, never think that a problem that has not been solved before can't be solved, or can't be solved in a much more elegant way. And so I ask people to always push. For me, there were moments in the career where you'd be given a problem and people say, this has never been done before. I can't imagine how we would solve it, because it's a fairly intractable design problem. And I often found, just because a problem has not been solved before, it does not mean you can't come up with a fundamentally different solution to it than could ever be done before. And the third thing I would tell you is, a big part of particularly when you're leading an organization, is knowing what problems are worth solving and what problems are not worth solving. And so a lot of, when you move from an individual programmer to being a manager to being a leader of a product team, I think the biggest challenge is knowing what you want the best people in the development organization to go focus on is almost as important as managing the day-to-day project. Because any great piece of software takes 2-3 years before it reaches maturity. And so you have to know, you have to have the sort of guts or fortitude to make a bet on a design decision and on, hey, we're going to go invent a class of software over there, before people actually have all the data to prove that you're right. And those decisions that you make under uncertainty, many people are uncomfortable with that. They're like, I need every last fact to tell me it's going to be the right decision. And many of the big decisions you have to take, you got to be comfortable doing with uncertainty. So those were some of the things, having a good systems view of it, because many people, when they're working on a program, they're focused on one tiny piece of code or one part of the design, but they don't understand the overall design. That's one. Second, focusing on simplifying the design, because often I've seen people write way too complicated code to do something when you could do it with a lot less and much simpler code. The third is, being brave enough when somebody tells you, hey, this problem's never been solved before, or this is the way we've solved it and it's very hard to do. It doesn't say you can't come up with a much more elegant and simpler design than what people thought before. And just because a problem had never been solved doesn't mean you can't take it on. And lastly, being comfortable making decisions with uncertainty. Many people expect to have absolute certainty on the outcome before they're willing to take a decision. And frankly, you're often too late if you wait for that. Those were, I think, some of the lessons, frankly, I had to learn as I went through.
Yeah, and I think those lessons are echoed among entrepreneurs as well. A lot of entrepreneurs are dealing with uncertainty on a day-to-day basis when they're building startup companies. Yes. And a lot of developers in our audience may be budding, aspiring entrepreneurs who are currently maintaining open source projects.
Yes.
And may also have to deal with that uncertainty in their life.
Yes. And it's, the big breakthroughs, people often say, customers tell you what to build. Customers articulate a problem. They never actually precisely tell you what the real solution to it is. And, the other thing I tell you, that's, so you have to be willing to, the real big bets and the real transformational things come from recognizing a need, but building something before the market tells you it's reality, or if that's where the market's going. The other thing I tell you is people often confuse supply and demand. They say, well, nobody really wants something. And you ask, why is that? Well, look, nobody's buying any of it. But then you tell them, hey, nobody's offering to sell them something like it. And that's why nobody's buying it. I tell people, if a Martian landed in California, he'd think everybody loved to drive in California. And, because you see everybody in the cars and everybody's driving. And so Martian would go back to Mars and say, that driverless stuff they're talking about, there's no demand for it. But in reality, I would say if people knew they could be driven safely, at least 60% or some large number of people would say, hey, I don't want to drive. I really don't enjoy driving. I'm doing it because I have to. And so often I've also seen people mistaking, when you, in thinking about innovation and what new ideas they can come up with, they often mistake it by saying, you look at the current state of reality and you say, hey, that's what's real. And they don't realize the only reason it's real is nobody's offering an alternative.
Wow. Yeah, that's so well said, Thomas. And I think that what you're saying is actually also kind of embodied in some of the lean startup principles through customer development that Eric Ries and the other folks in that movement have kind of championed over the last few years. And one of the things that I've noticed is that there's oftentimes a visionary who has a vision of the future, and the customers don't tell you about that vision. You have to create that vision yourself.
That's right.
And maybe you validate that against the customer somehow. That's right. Through customer interviews.
That's right. And sometimes it's even harder than that, Ed, to be frank. Sometimes you actually have to build it, and then until you show it to them, they don't go, oh my God, if I could get that, it'd be amazing.
Exactly. So internally within Oracle, when you guys are thinking about innovating within Oracle, how do you go about organizing innovation? Do you guys do innovation through internal innovation? Is it through acquisition? Is it through venture? And how do you keep innovating in these kinds of ways in an organization so large?
It's a good question. I mean, to be frank, if you are going to be a company that's going to exist for multiple generations, you have to have the ability to innovate organically. You can't just depend on buying things. If you just depend on buying things, you become a distributor. And that's at least not what I wanted Oracle to be. And that's not the culture at Oracle. So we certainly acquire things, but the big innovations have come from what we've built ourselves. And so I'll tell you that the model, there's no exact science to innovation. Anybody who tells you I can prescriptively tell you how to innovate, I think is not being realistic. And to us, it comes down to 3 or 4 things. The first one is, finding the right people. The second one is making sure you're willing to take risk. And are you taking sufficient big risks? The third one is knowing how to be frank, in a bigger company like Oracle, knowing how to budget and shift resources to the right priorities. And then the last one is knowing there's a judgment on how long to continue with something versus learning how to cut it off. And let me explain each one just briefly. Finding the right people and fostering a culture of that, you've got to feel comfortable giving people a chance to innovate on, and often the idea of innovation comes from, there's a lot of good people in the world, but I would say from an engineering point of view, I found There are people who can come up with an idea, and there's others who are skilled who can take an idea and implement it. But you shouldn't mix up the two. And often I tell people, imagine if you had a bunch of really skilled painters, but Michelangelo didn't exist. Sistine Chapel wouldn't quite look the way it is. It would have a lot of beautiful colors on it, but it probably wouldn't look the way it is. And so you have to be willing to get those creative people who have the ideas. And that's a key thing for any great company. The second is you have to be willing to take risks. And to be honest with you, taking risk is really something a lot of companies, a lot of organizations say they do, but they truly, when faced with, I'll be frank, at Oracle, we have a lot of products today, and we've always had a lot of products. If you just counted every single request that customers had for features in those products, we could keep busy for the next 100 years. And you have to say, these products are reaching a certain set of maturity, and they're not going to be important 5, 10 years from now. So we're going to take some of our best people. I'm going to make a bet on the future. And that is, when you do the bet, there is no spreadsheet and an ROI calculator that says how significant that outcome is going to be. But you have to be willing to take that risk. And there's no financial model that sits there and tells you, here's what it's going to be. That's got to be a belief system in where technology is going, as opposed to some spreadsheet that tells you exactly where it's going. So that's number 2. Number 3, you got to be willing to reward risk. You got to be, if you expected, one of the things I remember listening to the Williams sisters, who are tennis players, that they said, what's one of the things your dad taught you? Because their dad was a coach. And one of them was saying, the biggest thing my dad taught me is about forgiving myself for a bad point. And he used to tell me, if you mess up a point, forget about it and move on, because the next point's important. Whenever you take risks, you're going to fail on some. Nobody who's taken sufficient risk is going to have 100% batting average. And so you got to be willing to accept those failures and be willing to reward some of the people who were on a project that failed because it failed because of reasons, not because they did a bad implementation, but maybe there was no demand for it, right? And so that's the third thing. And the last one, I think, is you have to make a judgment call. Whenever you got a portfolio of stuff, projects, products, cloud services that people are building, some of them are going to mature and be successful, and some of them are going to not be successful. Just because it's, again, back to the same, if you're taking sufficient risks, some projects are down to fail. And what I've seen companies and organizations fail at is trying to get to that decision on which ones to keep going, because very few products are perfect on the V1 release, right? So you got to keep iterating and knowing which ones to iterate on and which ones to not iterate on, because fundamentally they're just not going to be successful. Often that's a judgment call too. And
let's actually dig into that for a second, because this is actually a fascinating subject. So Google is actually pretty well known for killing off a lot of their early innovation projects at Google. And I've met a lot of Google engineers who've been kind of frustrated by that. That they thought that the project still had potential, but it was cut off a little bit early. How do you make those judgment calls? How do you know when you should persist and when you should pivot to something else?
Yeah, so our model is the following. The way we measure engineers and executives and everything else, the first 2 years of a product's life cycle, 2 years is a long time. Right now, most of our focus is on building cloud services. And so we're typically doing a new software delivery at least twice a month. So over a 2-year period, that's a very long time in terms of cycles, right? So the first year, we measure people on 3 things. Customer satisfaction. I always say it's better to get 100 happy customers than 1,000 unhappy ones. Second is depth of capability and innovation for a particular customer segment. And I've always felt it's better to go and get a set of people happy rather than peanut buttering an investment across a lot of different customer segments. So that's the second thing. And the third one is true competitive differentiation. Do you have you solved an important customer problem, an important technical problem, fundamentally differently than everybody else approaches it? Did you follow me? So that's what we measure the first year and second year. And there's no revenue in the mix at all. Because in my view, trying to measure revenue too early leads often to a mistake where people try to spread too thin the feature set because they're like, hey, this customer segment, I can get a little business there. And over time, the products get warped because of that. Do you see what I mean?
Absolutely, yeah. In fact, like there's a healthy tension that also exists in the startup ecosystem for the same problem, because a lot of startups have the financial pressure through investors to actually get to revenue traction quickly. But it sounds like within Oracle, because you're a large organization, you actually have the benefit of being able to think more long-term about that innovation and not necessarily charge into revenue right away when it may not be appropriate yet.
That's right. And then once we get into year 3, year 4, we're going to look at 3 factors. First of all, are the existing customers unhappy? Because if you've got unhappy customers, you got to be truthful about it and accept it and look at it as, is that because of a lack of product maturity, or is there something we're just not solving the right requirement, right? And then secondly, or if the product's doing well, can you sustain the kind of rate of innovation, and can you sustain kind of pricing differentiation, et cetera, to allow you to get revenue growth? And so starting in year 3 or year 4, we measure kind of growth of the business. If the product is not doing well, the central thing I've always told people in my organization is you got to make a decision about whether to continue or to change direction. And that decision, I think often, what I've found with decision making that people aren't comfortable with is being able to communicate a decision. And a lot of people want to get 100% of their organization to accept the decision or to believe in the decision. And my view is, any decision that you make under uncertain conditions, of which there are many, you're never going to get 100% agreement. So what you need to get people comfortable with is, what's the basis on which decisions are being made? Share that basis on a particular project with everybody so people understand, okay, this is what they're evaluating us on. Here's what they think is going well. Here's what's not going well. And you got to make a decision. And, you've got to, particularly as a project lead or a manager or an engineering VP, you got to feel comfortable making that call and not expect. And my general thing is people should respect your decision. You shouldn't want to get 100%, acceptance, if you follow me. And a lot of times people feel uncomfortable with having disagreements with people, so they never make a decision. But here's my view. The failure to make a decision is actually a problem for those people who are working on that project. Let's say you said, listen, 3 years out or 4 years out on a project, 3 years out, you could kill that project and pivot them to something more important. Managers get to that point and say, oh my God, I got to tell this person, man or woman, that we're going to shut down your project and move them to something else. Well, maybe the other project that they were going to work on would have been an amazing success. And by the fact that you didn't take a decision, the opportunity cost of that was you didn't give this person a chance to work on something else that was amazing. And so often, people find it uncomfortable to have that conversation. But if you think about it that way, I think people feel a lot more comfortable. They understand what they're being measured on, and we have transparency on that. We communicate clearly when we start measuring revenue, and it's not right on the first go. And then you have to have the fortitude as an individual responsible for a team to make the call, because often you're doing it for the best reason of all, which is for those very people who are working on something, and you want them to work on something that may have even more potential.
Now this is so interesting to me, because Oracle has such a vast product array that it seems inevitable to me that there would eventually be a project that's competitive with another product that Oracle has, or where there's maybe an idea for an initiative which would obsolete a product that has been financially very profitable in the past.
Yes.
You look at, for example, at Microsoft, right, where Microsoft Office has been the cash cow for Microsoft for quite a while in the early days, right? And then Google Docs kind of moving to kind of replace that. Microsoft I'm sure internally has thought quite a bit about that. So within Oracle, politically, how do you kind of overcome the challenge where there's a team that gets upset if another team is innovating that may actually be obsoleting their product over time?
It's not easy to do, but you got to. I'll give you a concrete example. You know, if you look at Oracle and you were somebody who followed Oracle between 1978 and 1991, 92, we were primarily a database company. In 1991, 92, we entered applications. And then between 92 and 2007, 2008, we were number 2 to SAP in applications. Now, it's interesting because particularly between 2003, 2004, and 2008, applications became a much more significant part of Oracle's business than during the 90s. In 2007, I remember a conversation with the applications team leaders, and I said, listen, guys, we've had a great run, but this technology is going to reach the end of its, let's say its maturity curve sometime over the next 10 years. And we can debate, is that 2016, 2017, 2020, and we got to build the next thing. And they said, what's the next thing? And I remember telling them, if you looked at an average company in 2006, 2007, you think every company wants to run their own ERP system. They want to, ERP is something used to track money and accounting and so on and so forth. And the reality was, people didn't actually want to run their ERP. They want to use an ERP system. They want to use an HR system. They want to use a CRM system, but they didn't want to operate it. In those days, the only way a big company could get it was they had to operate it themselves. And that was one of those where people used to mistake demand and supply, if you followed what I said earlier. So we made a decision, we're going to pick the best 2,600 engineers and have them go and build the next thing. And that was directly going to, over time, shift the focus of the company to delivering application software as a service on a cloud, rather than having people deliver stuff on premise the way we used to. It was a very difficult decision for people to accept, but we had to do it. And it was one of those where, again, we spent a lot of time talking to the management team about, this is what we're doing, here's why we're doing it. And my point of view was, if that's going to be the future, either we're going to invent that future or somebody else is going to, and we're dead anyway. And so it's one of those things. You got to have the belief system to accept that reality. And when you accept that reality, you got to then say, if that's the future, we need to start today or tomorrow, but not a day later. Not a day later, because somebody else is starting that future today. And so we moved people, and that part of the business is now enormously successful for us. And to be honest with you, throughout that journey, it was, because we had to shift our people before the reality that, in those days, people said software as a service or SaaS is for mid-market companies. And, people said nobody who's a $10 billion, $20 billion, $100 billion revenue company is going to run software as a service. And we're like, no, nobody says that, from small to big, anyone should be able to do it. And it was one of those decisions. And I remember that because we made that decision back when we did, it was done amidst uncertainty. Because in those days, upmarket ERP, SaaS, people said never going to happen. ERP in the cloud, never going to happen. And so you had to make that decision. We did, and it was, to be perfectly frank, taking our product line that was number 2 in the market, and then taking the best people off of that and saying we're going to build the next thing, particularly when they had 4 years of amazing success. I'll be honest, that was not easy.
Oh, of course, yeah. I mean, because they probably, a lot of people get a little bit emotionally attached to all the investment they've made into that previous product. And it's natural for engineers. You're very proud of your code. You want it to live on and be successful. Exactly. And sometimes you even confuse your own identity as a person with the company or the product that you've created. And you forget that you're an individual and that product isn't who you are, right? You're an individual and you're capable of great things beyond this product.
That's right. And the other thing I tell you, exactly right, Ed. And then the other thing I tell you is, not everybody has the ability to look around a corner. And many people are linear thinkers. They think if I incrementally improve what I've got, how can it get possibly any better? And sometimes you need the people who can look around the corner and say, no, there's another next thing around the corner that's going to change perception fundamentally, right? And if you like, when people ask me, tell me about what that means, and I said, if you look at all the phone manufacturers, wireless handset manufacturers, back in 2002, 2003, 2004, they were all competing on battery life and voice quality. Nobody ever thought that, hey, what happens if I give you a personal computer, a phone, an internet browser, and a camera, all in the form factor of a tiny device? How would that change things? And so many people, the hardest thing I found in getting these organizational changes have been the acceptance in the people who are linear thinkers of the idea of somebody who's looking around the corner. Because those things that look around the corner are the things that can really disrupt you.
That's great. Thanks, Thomas. So let's move on to some other interesting topics here. So one thing that personally is fascinating to me is just the vast array of software being developed at Oracle. And most companies don't have so many products within their organizations, but there are, I'm sure, audience members here that work at enterprises that do have a variety of products and engineering efforts going on. So what can they learn from how you are organized about your software development efforts? Because with so many software products, thousands of them at Oracle, I'm sure it's hard to just even keep track of them. So how do you go about managing that process organization-wide?
So organization-wide, our general model is to get groups. We like to have smaller teams work as cohesive units with accountability and responsibility. You see what I mean? So we give them the freedom, but we also give them the responsibility. So that it's basically, our products are organized as multi-function teams. Multi-function teams are product development operations, if they're running a cloud offering, quality assurance, product, what we call product design, which is user experience people who do our user interface design, and product managers. And they're all together, and they're given autonomy they're given the responsibility to build a product or a cloud service, and they're responsible for also operationally making sure that's viable. And so we give them the responsibility, but also they're accountable. Generally, we don't have a lot of matrixed management. We don't believe in that. We think if you're an engineer if you're the head of a product team, you should have the resources and the responsibility for delivering it, rather than saying, well, you have a hard time doing it because you've got dependencies on tons and tons of people. And so that's been the model that we have internally. All of our software is now done, virtually all of our software is done as sprints. We use a variety of open source tools within Oracle. We build on a continuous integration basis. Everybody writes code, checks into Git. We do continuous build out of that. We do dependency management using Maven. Everybody writes once you go through a continuous build and development cycle, we have a continuous integration pipeline where coming out of the build, you have a test suite. The test suite has machine learning that says, based on the check-ins, I know exactly what test to run. Those tests then kick off a request on our compute farm, which runs on our cloud, our compute cloud, and says, here's a topology I need to spin up because I need to run these tests for this piece of software. We run the tests, we archive the logs into an object store, we quiesce the compute and hand it off to the next thing. And so that process, that whole engineering pipeline, we've automated so that people can continuously build and run tests. And the idea is to bring that customer experience. What's the customer going to see when your code gets into production, right in front of the developer as quickly as possible?
And do you mandate any use of these tools or processes across the company, or do you give complete autonomy to each team?
We mandate certain things. so that we don't have just complete chaos, and we don't want people constantly trying to reinvent some basic wheels, right? So like source control, we have only 2 flavors at Oracle because we think those are good, and we don't need 50 different source control systems. Test tools, for example, we believe in test-driven development, and we also believe in testing through APIs rather than just through UI. So there's a lot of things we've done with an open source tool called Selenium that we use widely within the company. But then, there's always things like, hey, I need to do load testing, and I'd like to use a slightly different tool. And we have a process to allow people to request other things, and where appropriate, we say fine. So it's a balance. Part of it also is, we don't like teams unnecessarily duplicating technology. You see what I mean? So, for example, we have applications, and the applications guys write this stuff on top of our database. One of the reasons we like to have the same tool set is when the database guys ship a software release, they actually run applications tests as part of it to make sure they quality assure it with real workload, if you follow me. And if all the teams use different test tools, you can never share tests across these teams. So you then go, why did you break me? Well, I couldn't run your test because I don't know what test framework you're using. So there's things we've standardized, and then there's obviously things that we allow differences as well.
And do you encourage internal teams to use Oracle software and Oracle products primarily, or are you encouraging them to use third-party products as well? And how do you even find out what's even available to me as an engineer within Oracle? I mean, with such a wide variety of software that's happening internally, how do I even know what I can tap into so I don't create redundancy for what's already been worked on?
Yeah. So there's so open source. I mean, we use tons of open source technology within development at Oracle. We use like frameworks wise, for example, we use Kafka, Spark, Apache Spark, a whole ecosystem around Hadoop, Tachyon, et cetera, to run our big data infrastructure. We use Chef, to a lesser extent Puppet. Some people use Ansible for what we call build automation. A lot of the tools that you see in open source for dependency management, et cetera, we use standard. And then there's a whole range of what we would consider technology like Elasticsearch, Kibana. All of our cloud infrastructure is based on a lot of these standard tools that everybody gets off the web. And so the idea is you should be able to run an instantiate a workload, deploy the software on it. The instrumentation is done using open source. The analytics infrastructure, what we call our monitoring and intelligence infrastructure, is based on open source. So there's a lot of standard things we do with that. Now, the way we do that is we pull in an official build of the open source technology into a master repo at Oracle so that everybody knows which ones to use. And we pre-clear the licenses, and they go off of that. And so the benefit of that is when we go into our cloud production environments, which are millions and millions of servers, we don't have 38 flavors of this stuff that all have to be patched differently and maintained differently. And so our general model is we encourage people to use the appropriate technology to fit the right need. And if there is a set of open source technology that we think is important, I work with the managers to get all of that into a master repo, and then everybody can use off of that.
Makes sense. And so so if you kind of think about kind of Oracle's acquisition of Sun and the current Oracle stewardship of Java and the Java programming language, how do you think that's gone so far? Like, if you were to kind of create a report card for Oracle in terms of that corporate stewardship, how do you rate Oracle's historical stewardship, and what do you think could be done better in the future? What do you think's gone well? What has not gone well? What do you think about that in general?
So if I look technologically at Java itself, when we acquired Sun, for a variety of reasons, there'd be no release of a new Java language for a number of years. It was Java 5, and it had stopped there. There's sort of been almost a 5-year gap between JDK 5 and 6. So when we took it over, one of the things I felt was that we needed to get new vibrancy in the Java language itself. And it's both, to me, there were two aspects to it. Both, I think three key things. First of all, there were new programming constructs that were coming along in other languages that were reflecting gaps in the Java language specification itself. Array types. I mean, there's a long list of them. The second is there were, fundamental changes in hardware architecture. When I say hardware architecture, for example, if you put yourself back in 2009, the number of cores on a processor were tiny, and there was no persistent memory. There was no such thing as persistent memory or non-volatile memory. And the amount of DRAM you got in a box was, a high-end box was 256 gig. Today, you've got 44 cores, easily like a terabyte on any kind of high-end computer, and things like non-volatile, where you can frankly do amazingly fast boot off of non-volatile that you couldn't do before because you were booting off disk somewhere else. Do you follow me? So a lot of our focus in Java has been, one, evolving the language so it gets a richness of expression, particularly being frank, looking at where other languages had constructs that Java didn't have. The second is evolving it architecturally to supporting modern hardware, so that it can do, like, for example, pauseless garbage collection was a feature we introduced in Java 8, so that, and there's more coming in Java 9, so that you can, if you have a terabyte of memory and you say, my God, I'm going to pause the VM for like 30 minutes to garbage collect, that's not going to work, right? So, and then the third thing we're doing is, we think that Java, the VM, can be a good runtime for other programming languages. And so a lot of our work has been around that area of innovation, if you will. And we've got into a cadence where we've delivered 7, 8. We're well on the path with 9. And I think the community in general has understood that they're going to get new JDK releases well. And then the Open JDK project has gone really well, working with Red Hat and a number of partners. Now, since you asked me what hasn't gone well, I think there's been a lot of noise about vulnerabilities in Java, and I would say the net of it boils down to two things. First of all, Java as a server language has had very few vulnerabilities. Almost all the vulnerabilities have existed in the the client-side framework, if you will, AWT, Swing, that that area of code. Increasingly, to be perfectly frank, we see JavaScript as the client side. People build the business logic and backend in Java. They expose RESTful APIs, and then the client framework is increasingly in JavaScript. So the thing, I think there's been a lot of noise. Part of it was, unfortunately, people didn't update their client versions as quickly. So even though there may be fixes in the latest versions of Java that protect against some of the vulnerabilities, people were just not updating it. So we then went to a more aggressive model where we do auto-update it, which caused a bunch of people to be unhappy because they said, you're auto-updating it underneath me. I think that most of it, in my view, is things that will be, will no longer be relevant as we go forward, because a lot of those issues have now been fixed.
Great, thank you, Thomas. So we have a question from the audience here. The number one question with 177 votes is, how does Oracle see the rise of NoSQL?
Yeah, it's a great question. I'll tell you honestly, I'll address it more broadly, NoSQL and Hadoop. Many people asked me, when Hadoop came along, what's your position on Hadoop? And I said, to be perfectly frank with you, Hadoop does something really well. It gives you the ability to store unstructured data flexibly really, really well. Same thing with key value stores. They give you, the ability to persist it really well, and relational systems were not written for that purpose. Now, however, like even back then, I tell people, if you look at, a lot of people used to ask me, why does MapReduce not solve my analytics problem? And I said, you should be careful on what you mean by that, because when you have Hadoop as a data lake, you can persist data in it. MapReduce gives you massive parallelism in terms of being able to run lots of queries in parallel on it. But what it doesn't do well is give you a guaranteed response time. Like when I calculate the time it takes to do a query, why doesn't it tell me I can give you an answer in like 15 seconds or 2 seconds? And the reason of it is at the heart of it, right? At the heart of it, I think it is the fact that because you have flexible storage, when I say, tell me how many people bought this particular product on this particular day, it's hard to do the calculation, because in order to calculate that, you need to know exactly how many blocks I need to go offset on this file system to load that data and join it with this other piece of data. You see what I mean? So the very fact that it was very flexible from a storage point of view meant it's very hard to be able to give you a guaranteed response time on finishing a query. And so we predicted back then that most people, when you look at the Hadoop world, really don't want to look at all the data in Hadoop. They want to look at a subset of the data. They like the fact that it's all persisted there in case they want to analyze it, but they don't want to look at all the data. And Spark, S-P-A-R-K, to us is a great technology because it lets you pull the subset of data into memory to be able to analyze. And because it's primarily going against memory, you get a much more predictable response time. You see what I mean? Now, if you look at NoSQL does 3 things really well. And our model is, we think it's a good idea. Those are real use cases. And we're also evolving the relational system to support that. So what does it do really well? First, it gives you the ability to persist data in a key value model. And lots of data in the world is key value oriented, right? Now, we think there are really 2 separate types of NoSQL databases. There are document-oriented databases and traditional key value-oriented databases. To us, something like a Couchbase or a MongoDB would be a document-oriented database as opposed to a key value-oriented database. But anyway, that's semantics. The second thing they do is they give you the ability to horizontally scale out with sharding. The third they give you is a model called eventual consistency, which means you don't have to do ACID transactions. And lastly, for upgrades, for example, you can evolve the schema. Did you follow me? So when I evolve the schema, you don't have to do you can roll the schema and without having to do like an ETL type upgrade. Now, our general view is that's really good. There's a lot of data in the world that's structured like that. And people have gotten, instead of accepting the fact that there's a use case for it, they get hung up on what's the language you use to access it. NoSQL, if you follow me. When in fact, if you're dealing with documented-oriented data, you'd want to deal with it largely as post and get in the first place. Did you follow me? Now, what we're doing is not only are we building out a NoSQL solution of our own, but we're also bringing a lot of these characteristics to Oracle. And so we're adding sharding to Oracle. We're adding eventual consistency. In addition to ACID transactions to Oracle, we're adding the ability to do scale out with Oracle, so you can horizontally scale. And we're looking at a project on how to do schema evolution, where you evolve the schema without having to do a traditional upgrade type model. And so my general view, if there's a technology that comes along in the market, you have to be truthful about what it does well and decide, do you evolve that technology, or do you also incorporate some of that technology into what you already have and make your technology better? And I found that where organizations fail is when they get overly, proud of what they have and they get into a non-invented here syndrome, if you follow me.
I do, and in fact, I'm a big fan of Spark myself, actually. I remember when they were just getting traction, they're kind of trying to decide, do we monetize this thing? Do we open source it? And I thought they made a pretty smart move. They decided just to join with Apache. Let's not charge for support or an enterprise version of this, right? That way, politically, we can partner with the other vendors in the space, the Clouderas of the world, right? The Hortonworks of the world, and I looked at the code for Spark, and I saw that instead of doing pages and pages of MapReduce, you could get your job done with maybe half a page of Spark code. So have you guys thought about maybe making your own kind of enterprise support version of Spark? Is that in the roadmap at all?
Yeah, we're actually doing it, and it's going to be available very, very shortly. So when we looked at it, to be frank, Ed, we looked at it and said, listen, if you look at Hadoop, if you wanted to be controversial, okay, I'm not suggesting necessarily this, but I'm just going to give you a hypothesis. You could argue over time, Hadoop itself just becomes the file system. In fact, the name of it is Hadoop Distributed File System. And file systems to some extent commoditize over time because they're just managing files. Today, on top of Hadoop, so you could argue there's HBase and Hadoop that manage the files. You could argue you have a metastore where you store your metadata. On top of that, you have a resource manager, Yarn, that manages resources. But if the primary and then there used to be a set of computational engines, right? Computational engines, MapReduce, Pig, Hive, etc. But to be perfectly frank, nobody was really happy with any of those computation engines. And Spark, to us, has the promise of being the really great computational engine, the calculation engine. And what's interesting about Spark to us is, there's one irony, and that is Spark actually is a SQL dialect. If you looked at the Hadoop space and you go and read the press back in 2007, 2008, people are like, they're never going to do Hadoop. SQL over Hadoop is nonsense. And ironically, Spark, frankly, if you look at Spark code, it looks awfully like SQL. So that's one irony. The second thing, if you look at our strategy has never been to, we don't see our value in building, forking Hadoop, for example. Right? Our general thing is people like the open source distribution. We should use that. And our value comes from building tools on top of Hadoop. And so we're building 6 tools. Our general thing is people want to load data into Hadoop. So there's an ETL, like a cleansing, data quality, streaming process to put data into Hadoop or into Kafka. Then there's a set of tools to do query analysis, discovery for data in front of Hadoop. So a business user can sit in a dashboarding tool and access data underneath, and it basically use Spark and Spark streaming underneath the covers to search data in Hadoop. People also want to do statistical analysis, and so our value is over time providing an elastically scalable Hadoop runtime with Spark on top of it, so you can elastically get Spark. You can add streaming with Kafka, and then on top of that is a set of tools to do analysis. And that's where our differentiation will come from.
I love the vision. Thank you, Thomas. So we're just about out of time. We only have 2 minutes left. So I guess maybe let's close up with just a general interest question that I'm sure there's audience members dying to know this. What's it like working with Larry Ellison?
He's surprisingly, he's an engineer. And so, a lot of our discussions are technical in nature. He's surprisingly deep on product. And, he's got, the biggest thing I find with him is he's not shy about wanting to bet the future of the company on something big. Many executives, when it comes to, are you going to bet the future of the company on this particular thing or this particular technology? For us, right now, it's cloud computing. We believe that 100% of the world, we want to make every piece of our software, any infrastructure, compute, storage, network, accessible to any human being, anywhere in the world through a browser or phone. If you look at Oracle, what it was in 2010, 2011, and that vision where you can go up, put in your credit card, get access to a software, any kind of software from anywhere in the world, that's a drastic change. And I think he's one of those people who, once he gets convinced that it's a better model for computing, I think he follows his convictions. And because as a technical person, it's easy to get decisions done with him because he's also willing to make the leap of faith on some of these big bets that we have to make. And I've worked with him a long time, as have many, many people at Oracle. We work as a team, and a lot of my executives who work for me have worked with him a long time, and they're really sharp guys, so it's generally a very easy collaboration.
That's great, Thomas. Well, thank you so much for this. It's been wonderful talking to you. I really, really enjoyed it, and I think our audience learned a lot. So I just want to really, really just express my gratitude. By you being here today, you've helped coding nonprofits. If you enjoyed Thomas's talk, please consider making a donation to a coding nonprofit of your choice. Also, Thomas, by the way, is very involved in a very important initiative called the Heart Walk, which I also encourage developers to sponsor as well if you have that opportunity down the road. In fact, Thomas's sponsoring of the Heart Walk is part of the original inspiration that I had for part of the Hack Summit, for the nonprofit involvement. I saw what he was doing, and I thought, like that's helping nonprofits is really the way to go. So thank you for that, Thomas.
Thank you, Ed. Thank you for having me.
You're welcome. Okay, guys, so we'll be back very soon with Joel Spolsky from Stack Overflow. He's going to be giving a great presentation. And again, Thomas, thanks again. We'll talk to you soon.
Bye-bye.